Howdy. SciTech Daily. Decades-old equation upended. Ice flow is more sensitive to stress than previously thought. Becky Ham, Massachusetts Institute of Technology. The rate of glacier ice flow is more sensitive to stress than previously calculated, according to a new study by MIT researchers that upends a decades-old equation used to describe ice flow. Changes to a key ice flow equation could refine estimates of sea level rise. The rate of glacier ice flow is more sensitive to stress than. How many times we have to read the same thing? Okay, now let's continue just here. Stress in this case refers to the forces acting on Antarctic glaciers, which are primarily influenced by gravity that drags the ice down towards lower elevations. Viscous glacier ice flows really similarly to honey, explains Joanna Milstein, a PhD student in the Glacier Dynamics and Remote Sensing Group and lead author of the study. If you squeeze honey into the center of a piece of toast and it piles up there before oozing outward, that's the exact same motion that's happening for ice. Really? How? Who's squeezing the toast? The revision to the equation proposed by Milstein and her colleagues should improve models for making predictions about the ice flow of glaciers. This could help glaciologists predict how Antarctic ice flow might contribute to the future sea level rise. Although Milstein has said the equation change is unlikely to raise estimates of sea level rise beyond the maximum levels already predicted under climate change models. Almost all our uncertainties about sea level rise coming from Antarctica have to do with the physics of ice flow, though this will hopefully be a constraint on that uncertainty, she says. Other authors on the paper published in Nature Communication, Earth and Environment include Brent Mincheff, the Cecil and Ida Green, Career Development Professor in MIT Department of Earth, Atmospheric and Planetary Sciences, and Samuel Pegler, a University Academic Fellow at the University of Leeds. Benefits of Big Data. The equation in question, called Glanz flow law, is the most widely used equation to describe viscous ice flow. It was developed in 1958 by British scientist J.W. Glenn, one of the few glaciologists working on the physics of ice flow in the 1950s, according to Milstein. With relatively few scientists working in the field until recently, along with the remoteness and inaccessibility of the most glacier ice sheets, there were few attempts to calibrate Glenn's flow outside the lab until recently. In the recent study, Milstein and her colleagues took advantage of a new wealth of satellite imagery of Antarctic ice shelves, the floating extensions of the continent's ice sheet, to revise the stress exponent of the flow law. In 2002, this major ice shelf Larsen B collapsed in Antarctica, and we all have, from that collapse, is two satellite images that are a month apart, she says. Now, over that time area, we can get imagery every 6 days. The new analysis shows that the ice flow in the most dynamic, fastest changing regions of Antarctica, the ice shelves, which basically hold back and hug the interior of the continental ice, is more sensitive to stress than commonly assumed. Milstein says she's optimistic that the growing record of satellite data will help capture rapid changes on Antarctica in the future, providing insights into the underlying physical processes of the glaciers. Underlying physical processes of glaciers. I still think I came to the conclusion that glaciers are volcanoes. And, or actually, glaciers are a lava stream made out of water, a contemporary lava stream. Since Mount St. Helens, for example, is a cryptodome and it's growing a glacier inside the caldera. It's the world's fastest growing glacier in a caldera of a volcano. So it might be not to be too far-fetched to think that everywhere where you have a glacier, you might have a volcano too, because that's where the whole glacier comes from, where it gets fed, where it gets the water. But anyway, but stress isn't the only thing that affects ice flow, the researchers note. Other parts of the flow law equation represent differences in temperature, ice grain size, and orientations, and impurities and water contained in the ice, all of which can alter flow velocity. Factors like temperature could be especially important in understanding how ice flow impacts sea level rise in the future. Cracking under strain. Milstein and the colleagues are also studying the mechanics of ice sheet collapse, which involves different physical models than those used to understand the ice flow problem. The cracking and breaking of ice is what we're working on now, using strain rate observations. The researchers used INSAR, radar images of Earth's surface collected by satellites to observe deformations of the ice sheets that can be used to make precise measurements of strain. By observing areas of ice with high strain rates, they hope to better understand the rate at which crevasses and rifts propagate to trigger collapse. Okay. If you think about glaciers, if you just for 1 second would imagine whatever glacier is just a lava flow made out of water. So it's basically really gentle because it just melts away. It's not poisonous, you know. But times are changing, so there might be something else coming up there too than just water. And who knows, maybe the water is increasing in temperature in some point as we go further in the big cosmic cycle. But I leave it here. It's really interesting. Glaciers, cosmic cycles. Be aware. Thanks. Bye.